This is section 3.2, and we're going to be looking at applications of radian measure. For the first definition, let's look at a circle. And if I just take out a piece of it, do you remember from the last section that we could label the radius of the circle with r, we could label the length of the arc with s, and then we could label the measure of the angle with theta? Well, if theta is in radians, then we came up with the formula theta is equal to s over r. Well, we can think of this as a proportion. We could just put theta over 1. And then if we solve this for s, we could cross multiply. So if s times 1 is equal to s, and then r times theta on the other side. So we have s is equal to r theta. We're going to be using this equation in most of this section, 3.2. So s is equal to r theta as long as theta is in radians. So it has to be in radians and not degrees. So you'll be working on some problems with that formula. And then let's look at the last part of this section where you'll be dealing with the area of a sector of a circle. You can think of the sector of a circle as a piece of pie. So if we just had a little piece of a circle, that would be the inside there is the sector. And so the sector of a circle is a portion of the interior of a circle intercepted by a central angle. So the area is the area that's inside of that sector. Let me show you where it comes from. If we think of a whole circle, so a whole circle, this has an area, and I'm going to use a script A because we're using capital A to describe an angle on a triangle. So script A, area is equal to pi r squared. But what if we're just looking at a sector? The sector is just part of the circle. Well, then the area would be equal to the part where we're just dealing with, if we take the whole circle, that the whole angle would be 2 pi, but the measure of just this angle, I'll just call that theta. So do you see how if we're just dealing with that part, it would just be theta over 2 pi. That'll describe just that part. If we multiply that by pi over r squared, then we'll have the fraction of the circle. And then do you see how the pi's divide out? So we'll have 1/2 and then theta r squared. And you can see that's the formula for the area of a sector. As in the formula for the arc length, the value of theta must be in radians. So if you're given a problem and they give you degrees, you want to convert that to radians first, and then you can use the formula.